As you know, microcontrollers have limited input and output pins, so we need a very efficient circuit designed to save some input and output pins for other designs. For example, 7 segments have 8 pins for segment displays and 1 pin for power connection. So, we need 9 pins for one 7-segment display. We can use the shift register to save the microcontroller pins. In this video tutorial, I will show you how to interface the 74HC595 shift register with the 8051 microcontroller and save some microcontroller pins. Let's start the video. Welcome to Star Technology 5G. The 74HC595 consists of an 8-bit shift registers and an 8-bit D-type latch parallel outputs. The shift register accepts serial data and provides parallel data to the 8-bit latch. How shift register work? For example, we have 00110011 bits data. We will give this data to the input of the shift register, and the shift register will provide us with parallel data at the output pins. When the first bit of data is transferred to the input of the shift register. After that we need to give him a clock pulse. After receiving the clock pulse, data is transferred to the first output of the pin Q0. After that, we will send the second bit of the data and give him a clock pulse. After receiving the clock pulse, the first bit of data is transferred to the second pin of the shift register, and the second data bit is transferred to the first pin of the shift register. After that we will send the third bit of the data and give him a clock pulse. After receiving the clock pulse, the first bit of data is transferred to the second pin of the shift register, and the second data bit is transferred to the third pin of the shift register. So, we will send one by one each bit of data and give him a clock pulse. After receiving each clock pulse, data is transferred to the next output pin of the shift register. When all 8 bits are transferred, this data is stored in the latches, so at the end we need to give him a latch clock pulse so the data is transferred to the output pins. We will do all these steps in our program. First, I will create a project in Microvision Keel. I already wrote the codes. I will paste this code here. Now I will explain these codes. SH clock bit P0.0, shift register clock pin 11. LA clock bit P0.1, shift register latch pin 12. SE data bit P0.2, shift register input data pin 14. DISP 1 bit P0.6. Display 1 positive supply. That is a common pin for display 1. DISP 2 bit P2.7. Display 2 positive supply. That is common pin for display 2. SW 1 bit P2.6. Switch 1 up counter. SW2 P2.7. Switch 2 down counter. Digit 1 equals 30H. Digit 1 at location 30H. Create a variable named digit 1 at RAM location 30H. Digit 2 is equal to 31H. Digit 2 at location 31H. Create a variable named digit 2 at RAM location 31H. Main program. Move digit 1 #0. Copy 0 to digit 1. Move digit 2 #0. Copy 0 to digit 2. That is initial value of the counter 00. Again. This is a label. A call MUX. Call multiplexing. Here is the multiplexing function. MUX. This is a label. Move DPTR-SEG codes. Copy 7 segments display codes to DPTR. Here are SEG codes. In this line we create a table for all digits in hex format. These are the same codes we used in the last video. Move A digit 1. Copy digit 1 to A. Move CA at the rate of A plus DPTR. Calculate hex code from DPTR and copy it into A. It will get the hex code from SEG codes and copy it into A. Call shift reg. Call shift register. Here is the shift register function. Shift reg. That is a label. Move R4-7. Copy 7 into R4. Data ser, that is label. RRCA. Rotate right with carry. This instruction rotates data from left to right. For example, if we have data 11001100, that is 8 bits of data. After this instruction the result will be 01100110. And copy the result in C. Move SE data C. Copy carry to serial data input pin. SE data is the serial input of the shift register. This serial input is connected with P0.2 pin of the microcontroller. After sending data to the serial input pin, clear SH clock. Send low clock to serial clock pin. Set bit SH clock. Send high clock to serial clock pin. DJNZ R4 data SER. Decrement R4, if not 0, jump to data SER. Now the value of R4 is 6. Before it was 7. It is not 0. So it will jump to data SER. Here is the data SER label. Again it will rotate. This time it becomes 00110011. And copy the result in C. Again it will send data to serial data. Clear SH clock. Send low clock to serial clock pin. Set bit SH clock. Send high clock to serial clock pin. And again, decrement R4. This time it becomes 5. And again it will repeat this loop. It will repeat this loop 7 times. When R4 becomes 0, it will exit from this loop. Now we have to give him the latch clock. Clear LA clock. Send low clock to serial latch pin. Set bit LA clock. Send high clock to serial latch pin. And return. Return from loop. Set bit DISP1. Turn on display 1. Call delay. Call time delay function. This delay keeps turning on display 1 for some time. Here is the delay function. We are using a single register delay function in this program. Clear DISP1. Turn off display 1. Move A digit 2. Copy digit 2 to A. Move CA at the rate of A plus DPTR. Calculate hex code from DPTR and copy it into A. It will get the hex code from SEG codes and copy it into A. Call shift reg. Call shift register. First, we use this loop for digit 1. Now this time we are using this loop to display the digit 2. Set bit DISP2. Turn on display 2. Call delay. Call time delay function. Clear DISP2. Turn off display 2. After multiplexing it will move to next line. JNB means jump if not bit. SW1 action 1. Check switch 1 status. If pressed, jump to action 1. JNBSW2 action 2. Check switch 2 status. If pressed, jump to action 2. Jump to again. And repeat this cycle again and again. If we press the switch, it will jump to action 1. Here is action 1 function. Call UPCNT. Call up counter. Here is the up counter function. UPCNT. This is the label. Move #10. Copy 10 to A. INC digit 1. Increment digit 1. Before we copied 0 to digit 1. Now digit 1 is equal to 1. CJNEA, digit 1, UPCNT exit. Compare A with digit 1, if not equal, UPCNT exit. If these two are not equal, it will jump to the up counter exit. Here is UPCNT exit. Return. Exit from loop. When the digit 1 will reach 10. Now both A and digit 1 are equal. Now it will move on to the next line. Move digit 1 #0. Copy 0 to digit 1. INC digit 2. Increment digit 2. CJNEA, digit 2, UPCNT exit. Compare A with digit 2, if not equal, UPCNT exit. If these two are not equal, it will jump to the up counter exit. UPCNT exit. Return. When digit 2 will reach 10. Now both A and digit 2 are equal. Now it will move on to the next line. Move digit 2 #0. Return. And it will increment the digit 1. If we press the switch 1, it will increment the counter value by 1. Call multiplexing. Call multiplexing and display the digits on 7 segments display. JNBSW1A1L1. Check switch 1 status. If pressed, jump to A1L1. So if we press the switch, it would repeat this loop. And when we release the switch, it will jump to the again label. And repeat this cycle again. If we press switch 2, it will jump to action 2. Here is action 2. Call DNCNT. Call down counter. Here is the countdown function. DNCNT. Move A255. Copy 255 to digit 1. Here we copy 10 into A. These two are overflow values. DEC digit 1. Decrement digit 1. CJNEA digit 1 DNCNT exit. Compare A with digit 1, if not equal, DNCNT exit. It will decrement the digit 1, for example, if 9, then 8. If not equal, it will jump to DNCNT exit. If both values are equal, then it will move to the next line. Move digit 1 9. Copy 9 to digit 1. DEC digit 2. Decrement digit 2. CJNEA digit 2 DNCNT exit. Compare A with digit 2, if not equal, DNCNT exit. If both values are equal, it will move to the next line. Move digit 2 9. And return. Call multiplexing. JNBSW2A2L1. Check switch 2 status. If pressed, jump to A2L1. So if we press the switch, it would repeat this loop. And when we release the switch, it will jump to the again label. And repeat this cycle again. Now click on the build target. Hex file created. No error, one warning. Now I will download this hex file into the microcontroller. Click on Microcontroller. Select File. Click on Start. Press switch 1. It will increment the counter value. If we press the switch 2, it will decrement the counter value. Thank you for watching. Please subscribe to Star Technology. Please like and share the video.